5.3. I'm going to briefly go over the ready and the go with you guys since it's review, but we also did spend a decent amount of time on this in class. So just a really quick review on the ready. There are 180 degrees inside the interior angle, or sorry, the sum of the interior angles of a triangle is 180 degrees. Whew. So, in the ready, you are being asked to find all of the missing angles, the interior angles of the triangle. Use what you know of triangles. You're going to have to pay attention to isosceles triangles, equilateral triangles, exterior angles of triangles, straight angles. So just a quick review. These symbols here, those mean congruent, which will help you identify if it's an isosceles or a equilateral triangle. Another thing that you guys need to remember is this means 90 degrees. Here we have what is called a straight angle. And a straight angle is 180 degrees. So if you have one angle, you have its supplement, which is two angles that add up to 180 degrees. So if you know this is 78, you can find the other side. In 5, you have vertical angles here. Vertical angles are formed by two intersecting lines, which then makes the angles formed congruent. And there are two pairs. But in this case, you're only having to focus on one pair. Here, this symbol means congruent, which will then help you with identifying what type of shape this entire quadrilateral is. So you could then use the properties of that quadrilateral to help you finish filling in its missing angles. And then in 8, please be careful with 8 because you're given what each angle is as an algebraic expression. So you will have to do some algebra here. And don't forget, the sum of the angles, all three of them, is 180. And you have 3 angle measures here. The sum of the angles is 180 degrees. So you can, just a hint, you have to find x first. Just a hint, if you were stuck on that. Then once you have x, you will need to plug in. All right. I'm going to skip the set for now. Let's go ahead and, well, let's look at 14. Sketch the three-dimensional object formed by rotating the figure about the x-axis. Think of a real-world object, but also think, what are the solids that are making the shape? Don't just get so stuck on, this is a dumbbell. Think of the types of solids. We have cylinders, we have cones. In the set, we're going to talk about frustum like we did in class. It might have a pyramid. There are a bunch of different shapes that create this three-dimensional figure. And I want you to think about that. If someone were to ask you to describe what it is, maybe somebody doesn't know what a dumbbell is. Maybe they need to be told using the geometric solids. So think about those terms, please, as you guys are drawing the three-dimensional figure. And don't forget, you must show that it is 3 dimensions. All right, let's talk about the go before we go back and finish the set. Solve for the missing side of a right triangle. When you are looking for the missing side of a right triangle, you are going to use the Pythagorean theorem. And what is the Pythagorean theorem? Okay, good. So we have a squared plus b squared equals c squared. There's only one thing you need to be very careful for in the Pythagorean theorem, and that is making sure that you remember that c squared is your hypotenuse. And the hypotenuse is the longest side. It is the side opposite your right angle. Now, a couple of you have expressed that you do need some help with the ones that involve the radicals. Now let's read the directions. Calculate the missing side in the right triangles. Give your answers in simplified radical form. That means you get to leave your answer as a square root, but it must be simplified. So no decimal answers here. So I am going to go ahead and let's do 19. It does have a square root in it. I'm going to identify C. C is the side opposite your right angle. So I'm going to have 5 squared plus 5 square rooted 2, all of it squared, will equal C squared. So when I square 5, I get 25. Now please be careful when you are squaring this. This becomes 25 times 2. 5 squared is 25. The square root of 2 squared, well, they're inverses of each other. So the square cancels the square root, so you're left with 2 equals C squared. So this is 25 plus 50, which is 75, equals C squared. Now I must square root both sides. So C is going to equal the square root of 75. But I cannot square root 75 without getting a decimal. But I remember the directions said that I need to rewrite this as a simplified radical. So I need to find the perfect square that is in 75. So this is 25 times 3. I can rewrite this as the square root of 25 times the square root of 3. And what is the square root of 25? The square root of 25 is 5, and I'm left with the square root of 3. There is your missing side. 5 square root of 3. So if you haven't simplified your square roots, please make sure you do go back and check to make sure that they can be simplified. Don't just be lazy and leave them. Don't be lazy and use your calculator. And if you do not remember how to simplify a square root from Math 2, you need to come back and get some help, please. I would be happy to help you with that before school lunch or after school. All right, let's go talk about the set. I'm going to do a lot of this with you. I know we did do this one in class, and if you weren't here, you missed it. Maybe we went a little bit too fast for you. You can catch up here. I will do the best I can to make this as easy as possible for you. So we are going to be finding the surface area of the Washington Monument, and then we're going to be finding the volume. The Washington Monument is created by 2 different shapes. So I'm going to work over here on the Washington Monument picture. We have a pyramid, and we have a frustum. Like in class, we talked about a frustum being created by taking a cone or a pyramid and chopping off its common vertex that all of those sides share. So we're taking off the tip of the pyramid, we're taking off the tip of the cone, and we are left with a frustum, which is a flat base on the top and the bottom. In this case, it's going to have a square base on the top and the bottom. The first thing we're going to find is the dimensions of the triangles that make up the pyramid. So dimensions are base and height. Well, we're given the base of the triangles as 34.5. So here's the triangle. Here's the base. Well, let me draw that better. Here's the base. Here's my triangle. I do not know the height of this triangle. I know the height of the pyramid, but I do not know the height of the triangle. The height of the triangle runs along the triangle, where the height of the pyramid runs inside the pyramid. Here's the height of your pyramid. The height of your triangle is bigger than the height of your pyramid because it has to lean to get to the top of the pyramid, so it must be longer. So when I put those two together, this actually creates a right triangle. So I have a right triangle that looks something like this, where the height of the pyramid is the 55.5. Now the base of this triangle is half of the base of the square. So 34.5 divided by 2 is 17.25. So now I need to find this missing side, which is the Pythagorean theorem. I'm not going to show all my work here. That is something that you guys can do. You can use your calculator. I'm going to just jump to the answer after this. So I go through, use my calculator, and I end up with 58.12. And both of these are in feet. So I have the dimensions of my triangle. Now I'm going to go to number 10, and it says find the area of each face of the pyramid. Well, the face is the triangle that we just found. So the formula for the area of a triangle is 1/2 base times height. So my base was 34.5. My height was 58.12. And I'm going to divide by 2. So let me plug this into my calculator. 34.5 times 58.12 divided by 2. One triangle is 1002.57 feet squared. That is one face. So find the area of each face. There are 4 faces. Each one is 1002. So I'm going to find what all 4 faces is, because I know I'm going to have to find the surface area. So 4 faces equal, let me make a note here. This is one face. 4 faces, I'm going to multiply this by 4, and I end up getting 4,010.28 feet squared. So that's all 4 faces put together. I'm going to need that for number 12, so I'm going to hold on to that for a minute. Now I'm going to move on to 11. Find the area of the 4 trapezoids that make up the faces of the frustum. So now we're looking at the bottom piece of the Washington Monument. And that bottom piece is starting big at the bottom, and then as it gets taller, it's leaning inside. So I'm looking at the formula that they're giving me here, which is base 1, which I'll say is the bottom, plus base 2, which is the top. So it's the length of your, here's base 1, here's base 2. So it's the top and bottom of the frustum divided by 2. What we need to find now is the height of the frustum. So remember when we did the pyramid, we were given the height of the pyramid itself, but we were not given the height of the triangle. It's the same thing here. We're given over here that the frustum is 500 feet from top to bottom, but that's a vertical height. What we need to find is the slant height. How tall is this trapezoid by itself? So it is being raised, sorry. Here's the 500 feet. Then it is being pushed in 10.25 feet. What we need to find is this height right here. Well, this makes another right triangle. This is a very small, narrow right triangle where this is 500. Here's my right angle, and this is 10.25. This is what I need to find. So I'm going to have to use the Pythagorean theorem again. So I'm going to go ahead and do that over here. 10.25 squared plus 500 squared will equal my height squared. So I'm going to use my calculator. I'm not going to show all the work for this. So 10.25 squared plus 500 squared, and then I'm going to square root that answer. And I end up with my height being 5.11 feet. So I'm going to plug that in over here. Sorry, I said 5.11. It's 500.11. So I'm going to plug in. I'm going to do all this multiplication and division. So 55 plus 34.5 And then I'm going to divide that by 2. And then I'm going to multiply that by 500.11. And I end up with an area of 22,379.92 feet squared. Now, if you're thinking, man, that height of that trapezoid is not very tall, it isn't going to be very tall. The entire frustum is 500 feet, and it only has a difference of 10.25 feet of it being pushed in. So the trapezoid doesn't need to be that much taller, because it's really tall already. Now, if we were moving it in more than the 10.25 feet, then yes, it would have to be a lot longer. But it was not pushed in that far. So it is not a very, very tall trapezoid compared to the height of the entire frustum. So I have found one face. And just like we did with the pyramid, there are 4 faces to this frustum. So I need to find all 4 faces. So I'm going to take this answer and I'm going to multiply it by 4. So 22,379.92 times 4, which gives me 89,519.68 feet squared. So I have all 4 faces of my triangle, of the pyramid. I have all 4 faces of my frustum. So now when I get to number 12 and it says find the total surface area, I'm going to take the faces from my pyramid and I'm going to add the faces from my frustum. So I'm going to let you go ahead and do that. You go back and you get your answer from number 10, which is the 410 point, what was it? 28. And then the 89,519.68, and you're going to add that together. So you guys can get that one. I don't need to finish that one for you. And then I'm going to just get you started on 13. I'm not going to take you through all of it. You guys can do the math part in your calculator, but I will help you set this up. So 13 is now asking for the total volume. So that's the pyramid plus the frustum. So since they're giving me the volume of the frustum formula first, let's do the frustum. So it's 1/3 height. Now it's the height of the frustum, not the height of the trapezoid. So I'm going to go back and I'm going to look at this picture. The height of the frustum from ground to top, it's the vertical height, is 500 feet. So this is going to be 500, and then it's times. A and B are the side lengths of each square. So we have a square bottom and we have a square top. The square bottom is 55, so I'll put 55 squared plus 55. Now it's the square of the top, which is 34.5. So you guys are going to go through and you're going to figure all of that out. And then it's plus the volume of the pyramid, which the formula is 1/3. Now let's talk about what L is, because L is not representative of the length of the pyramid. L is representative of the slant height. We call that, or we label that with an L. So let's really quickly talk about what slant height is. When I look back at my pyramid, I do have the height of the pyramid, which is the H in the formula, the 55.5, but I also need to know how much are those faces of the triangle slanting. And by plugging the slant height into the formula, I can figure out what the volume of this pyramid actually is. So the slant height, which we found, is the height of our triangle, so the 58.12. So 58.12 squared is my slant height, and the height of my entire pyramid was 55.5 feet. So you guys are going to go through, plug into your calculator. You do get 1 million and something. Take your time. Make sure you plug in correctly. The answer that does go with this, the answer booklet online, is not correct. It is off some. Trust your work. Again, it's 1 million and it's like 1,081,000 and something. Plug in slowly if you have to. Make sure you use parentheses where appropriate. All right, so that's it for 5.3. If you have any other questions, come in and see me, or we have our homework question day on Friday. So please feel free to ask then or come and see me before then. I will see you tomorrow.